I was like, you sure about that? I'm sure.
Welcome. Thank you for joining us for the first talk in this year's Dr. Bruce J. Nelson Distinguished Speaker Series. My name is Rachel Mayeri. I teach media studies at Harvey College, and I'm chair of the Nelson Planning Committee this year. We're excited that our Nelson Speaker Series theme is maker cultures. And the goal behind this topic is to intentionally think through the culture that we want to create for our new makerspace, which will be going up in the corner over there. It's called the Scott A. McGregor Computer Science Center, and it will open in spring 2021. We are also eager to explore what is meant by the term makerspace exactly, and what other forms it may take that defy a traditional definition. Each speaker in our series will be sure to share their own unique approach to makerspaces and the creative projects that they've produced as a result. So today we are very excited to begin this conversation with Garnet Hertz, the Canada Research Chair in Design and Media Studies and an Associate Professor in the Faculty of Design and Dynamic Media at Emily Carr University. Yeah. It's a mouthful. Yeah. For good reason. Before Garnet is further introduced, I'd like to acknowledge the generosity of the family of the late Bruce J. Nelson, class of 1974, who established this educational series to honor Bruce's memory. Bruce died unexpectedly in 1999, though not before having a tremendous impact on the many people whose lives he touched as an unconventional, eclectic, and irrepressible free spirit. He graduated from Harvey Med as an independent program of studies major, and later he earned his master's in computer science from Stanford and his PhD in computer science from Carnegie Mellon. At the time of his death, he was Chief Science Officer at Cisco Systems. We are honored and grateful to the Nelson family for the opportunity we have to each fall to host exceptional speakers who are at the forefront of their respective fields. So I also want to offer thanks to my fellow Nelson Series committee members for helping plan this year's series and bringing Garnet to campus. The faculty members, Chris Clark of the engineering department, Fred Leichter of the Rick and Susan Sontag Center for Collaborative Creativity, Calvin Reiswick of the chemistry department, and certainly Elise Sherpin, where are you? who was fundamental in organizing this wonderful event. It is now my pleasure to welcome Chris Clark to the podium to introduce Garnet.
So, welcome everyone. I'm going to say a few words about Garnet, and we'll go some. How many of you have looked at Garnet's website here and looked at some of the amazing things? And, yeah, it's really, really impressive. A few things about his art and research investigates culture, electronic art, and design. It's really, really diverse and unique, though. So when I started looking at some of his work a few months ago, because I wasn't aware of it, I was just blown away. I'm a roboticist. I'm from the engineering department, but I've gone through computer science, engineering. I failed at art back in high school. I thought I was going to be an artist. And so I'm a failed artist, I would say. And what I look at, what Garnet's done, is it's just crossed so many boundaries. And I think that's really sort of indicative of what I think the makerspace should be. So I've been building robots for years, and the amount of effort, the intensity, the passion that goes into just making something work it's crazy to me. And when I try to get the students through that, it's just so much. But when I look at Garnet's work, it's just bringing that to this whole other level, because it's not just making something function, it's getting a message across, it's becoming art, and it's allowing for everyone to see it in a totally different viewpoint than anything that I sort of think of what I do as an engineer. It's just, it crosses into something that I can't do. And I'm just so impressed that there are people like this who can do it. And what I'm hoping is that sort of our community can sort of be inspired by this and bring this type of design, art, all the way with things like engineering into our makerspace, so that we can sort of think about it, everything we do in this way, and not just sort of within our boundaries of I'm an electrical engineer or I'm an artist, but really be able to grow between these fields. Now Garnet has been so successful with all this stuff that he's actually shown his work in 15 different countries. He was awarded the 2008 Oscar Signorini Award in Robotic Art. His work is, popular press, New York Times, Wired, Washington Post, NPR, USA Today, NBC, CBS, TV Tokyo, and CNN headline news. And it just sort of shows you that with this work, it's actually relatable, transferable, and sort of palatable by so many different people. So with that, I hope you sort of are inspired by Garnet just as much as I am, and let's welcome him to the stage.
Thanks very much. That was like one of the most generous introductions I've had in a long time. Thanks for having me here. And in the spirit of Mr. Nelson's memory, hopefully we'll add some eclectic kind of mix to this and provide some context into the work that I do and the potentials that I see for building physical objects and things in electronics and robotics and 3D printing and all that other stuff, but also combining that with kind of a mentality out of the humanities, or things that question more about why society is the way it is, or why people why they are the way they are. So hope you enjoy it. So the way that I'm going to structure this talk is I'm going to give an overview of some different projects that I've built, and I'm going to pull out a few examples from a book that I published called Disobedient Electronics that shows how built objects and designed objects could work to promote different forms of social change, hopefully in an interesting way. So I'm currently in Vancouver, Canada. I had actually come down to Irvine. I did my grad studies at UC Irvine and did a PhD and postdoc in computer science and stuff like this. But I'm living in Vancouver right now. But if you see that other dot there by Saskatchewan, the gray kind of thing, that's where I grew up. And my dad is a mechanical engineer who studied vehicle research and alternate fuels. And so I grew up with, playing in a wind tunnel, and my dad working on research projects related to vehicles. So I think that has a real impact on my kind of mentality for building objects. So I currently work teaching industrial design, but it's in an art and design school, and my background is from art, did a PhD in humanities and postdoc in computer science. But I primarily teach industrial design and electronics, and how students can use tools like the Arduino or other microcontrollers to make things move, interact, and work with each other. I also teach classes related to CNC fabrication and 3D printing and that kind of stuff. So the school that I'm at is called Carr University. I'll save my bio because I had a bio introduction that was better than this anyways. So it's a relatively small 2,000 person school. I have a space, and it's called the Studio for Critical Making. Now, the main idea behind the lab that I'm running, and I wouldn't quite call it a maker space, it's more functions like my studio and the studio space for grad students that I'm working with, and different projects that I'm working with. But the approach that I take is to say engineering is absolutely essential to getting things done in the world and people not getting killed and things being safe. And it's super, super important and extremely challenging. At the same time, though, if you only look at building things as a simple problem-solving solution where you plug in, your MATLAB formula or whatever, and build your system to just deliver one thing, it's kind of selling short of what you can do in building objects and products and experimental type of devices. So in the work that I'm doing, I kind of say, yes, these standard kind of goals, efficiency, speed, usability, those are really essential in delivering real world products and solutions and research. However, there's a really rich heritage within the humanities and with anthropology and a number of different social sciences that look at more issues around what it means to kind of be a human or alive. What makes people tick, what things are beautiful, what things are ugly. And so it's taking this kind of humanities type of approach, instead of just solution solving, more the idea of raising questions and asking questions about how things are the way they are and whether there's alternate kind of futures and alternate kind of paths that are worth society taking. Hopefully this will be a bit more clear as at the end of my presentation. So I have embraced this term critical making, and the term was invented by a friend of mine who works in information studies, information science, and his take on people that are doing work related to science and technology studies or policy studies. His approach was that those kind of theoretical social types of research are very much augmented by those people learning some kind of engineering and prototyping skills in order to be able to prototype out the stuff that they're theorizing about. Okay? That if you're researching digital rights, copyright management as a topic, then it does make sense for you to get an RFID reader and writer and prototype some stuff and see how things work in the real world. Alternately, I come from more of a perspective of building stuff. Building stuff with electronics and robotics, and I'll show a few examples in a second. But my take on the using the term critical making is more a comment on the maker movement, which can be seen as kind of in some ways it was really got a launched head start and kind of explosion when 3D printers really kind of hit big time. There was a number of patents that expired, and there's a kind of a flood of 3D printing excitement around 2012. My take is that there are things like the field of design, engineering, art, industrial design that are very, very useful in order to, or in other words, a 3D printer on its own isn't really going to solve any kind of social problem. It really has to be married to other issues. And I come from more the experimental design kind of background. My take was that there's only so much you can get out of a doodad printed out of a 3D printer without it having some kind of application. And I had seen the work that was coming out of a lot of hacker spaces and maker spaces as being kind of like a Yoda head printed keychain, you know. And it is, that's quite a natural kind of starting place for building stuff and working with additive manufacturing, but it needs to kind of be more engaging. As well, there is a number, I kind of draw energy from a number of different ideas and concepts that different authors have put forward. This is a partial list of kind of some of the precedences for my work, but most of them are based off of the idea that objects do have a bias to them, whether you are really engineering for it or not. And typically they are designed for specific circumstances and things, and that can be quite useful, but there also are ways that objects being designed can exclude people, they can include different people, they can be built in different ways, and you can use that kind of power of building objects, tap in, some of the energy from the creative arts to kind of make industrial design a little bit more artistic. So the main idea with this idea of critical making is that people who are building stuff need to be aware of what's happening in society in general, and the flip side of it, that if people are just theorizing about society, that it makes sense for them to be involved in that hands-on type of work as well. So a few projects. This was a machine that I had made that takes a living insect, Madagascan hissing cockroach. Oops. Okay, so the way that this thing works is that there is like a computer trackball, like a computer mouse type thing that is disassembled, and the heavy kind of ball is replaced with a ping pong ball that's quite lightweight, and then there's this fairly big insect that is relatively slow moving and relatively easy to keep in captivity, with Velcro on its back and a kind of a specialized kind of seat belt harness system to keep the insect in place. And as they run on the ball, the sensors pick up and if you do electronics, you'll have a look and see that it's quite rudimentary. But the cockroach, as it turns right, the robot will turn right, and as it turns left, the robot will turn left. Now, what you're seeing in the front of this is a bank of lights. Now, at the time that I built this, I was very interested in robotics and the idea of cyborgs and kind of science fiction, but also the reality of contemporary robotic research. And insects were really kind of idolized in the field of robotics. You have neural networks from insects that are used to plan out navigation paths or to do wayfinding. You also have legs on robots being a very popular kind of thing because they can navigate things that wheels have a hard time doing. So in the field of robotics, there's kind of in some groups there are kind of a cockroach fetish that roboticists have. So in my case, it was sort of like a little bit of like a smart-ass kind of move to say like, okay, like if cockroaches are so good, why not actually try to use a living cockroach to do this? And so in the process, though, you end up with kind of the faults of a living thing when you put an insect onto a robot, and it behaves very differently than a computer just running it. For example, it's lazy. The thing. I should say that the lights in front are attached to proximity sensors, distance sensors that look out in front of the robot, and that if there's a obstacle from like this direction, it'll shine a light from this direction, and the cockroaches like to go into the dark. And the idea is that they scurry away from the light, therefore steering the robot away from hitting the obstacle. And object avoidance is a major thing if you're designing autonomous vehicles or self-driving cars and robots. Not hitting stuff is a pretty important kind of real-world kind of engineering problem. So this is kind of trying to throw a curveball into that, but you end up with a machine that kind of is quirky. The cockroaches love driving. Some of the they're not really characters, but they're insects. Some of the insects will drive the machine like mad and smash into stuff. Some will be completely lazy. Some will completely go in circles. It's kind of like working with students, so it really does. For me, it was kind of funny because I expect that you're going to have this great cyborg machine, but it's just kind of like lazy and strange, like people. Also, another project that I built is called Outrun. The way that this thing worked is that it took a classic sit-down coin-operated arcade cabinet from the 1980s and combined it with a electric golf cart. Okay, so actually it was I don't know if anybody's been to the arcade in Santa Cruz on the beach boardwalk, but they have all these like classic arcade games, and I came across this game that I used to play as a kid, and it was like, wow, I don't know if I've eaten too many deep fried Oreos or whatever, but I was kind of like, this is so weird. There's like a car in this building, and people are putting coins into it. It's like, wouldn't that be weird if funny if people could drive this thing out into the real world? And so in the case of this project, there's a computer vision system that looks in front of the car that tries to see roads. Now, I'm not a very good computer vision programmer. I mean, you basically have to do this properly. You need to, making a self-driving car is another, not hitting obstacles is another difficult thing. And so it built a very hacked together computer vision system that tried to find roads and then drew an 8-bit style augmented reality, like in the style of this old school game, to try to, and this is before Pokemon Go, before the mixed reality stuff that's going on. That's a guy that happened to pay for it, so thanks to him. It's really kind of a nightmare. And it was actually really inspired by my Canadian parents coming and visiting me in Irvine and blindly following the GPS around, going the wrong way up a off-ramp or something. Kind of inspired by my dad following GPS through Southern California. But in these projects, I tend to incorporate humor as a technique to kind of get people's attention, but then also I really enjoy kind of taking these simulations, like in whether it's in robotics or video games, and kind of like making that simulation kind of real or kind of unsimulating it. I'm actually going to skip this project. It's just a publishing project. Another project that I had built is called PhoneSafe. The way that this works is that, oops. So the way that this thing works, and I should say that I have 3 college-age children. I started having kids when I was quite young, in the middle of nowhere again, but was constantly kind of dealing with us just not being on our phones while we're eating dinner and stuff, and I'm like totally guilty of this as well. And so for a time we had kind of like a basket that we'd put our phones in during dinner and stuff like that, just to chat with each other a bit more, because we were constantly glued to our phones and on Twitter or Instagram or whatever. So I had kind of built this kiosk as kind of a machine kind of a mechanism to kind of like take away people's phones for a period of time. So the way that it works is that you stick your phone into this drum. It goes into this safe, and you can't retrieve it. And you're only left with a button that can add time with no way to reduce the time. And so the way that it works is that people will come up to it, and it's installed in galleries or museums or lobbies. And actually, from a manufacturing testing perspective, this project was complete hell working on, because if you have any kind of code problem, technical malfunction with sensors or whatever, you're kind of drilling, you're like turned into a bank safe cracking person drilling little holes to try to pop the door open and stuff like this. So you stick your phone in, you have the button, you press the button to add time, and you have to wait for it to count down. Now, granted, this is not, it's not meant to be like a real kind of product. It's meant to more just be a discussion. You end up having a lot of like more teenagers looking around, and I would have like stools and benches around that people would, like, they put their phone in, they add some time, they're like, okay, I'm participating in this interactive art thing, weird thing, whatever. But then somebody else comes up to it and starts pushing the button. They're like, no. Or they're like, they start, like, I haven't seen any fights break out over this, but definitely taking away somebody's phone is, it's a very personal thing that you have to, it's quite a sensitive thing that is very important to our lives. And I'm not necessarily proposing, that we all smash our phones and stuff like that. It's not, life is, much more complicated than that. But also there is something to be said about how society has changed with mobile phones. It's had a very big impact on our world. So as a general concept, I do enjoy kind of playing this kind of trickster role in kind of engineering shoes, kind of like an artist that's wearing like engineering shoes that has fun like poking around and kind of designing these like whimsical devices to kind of bring up other issues. This project, what happened to my fax book? Well, okay, this is all you're going to get about Fax Book. Fax Book is very short-lived, and it unfortunately didn't get a lot of venture capital funding. But the idea on this was, what if all the old fax machines in the world that are sitting around collecting dust in the back of some administrative office or your grandparents' basement, what if these could like be revived like vinyl is revived? And like, what if all the fears over personal privacy and Cambridge Analytica and all this other stuff, data hacking, data privacy and all this other stuff, what if people just kind of burnt out on this whole social networking thing and just use their old fax machines to fax back profiles and information? Turns out that the only person that actually really used Fax Book was my wife, to send me faxes very late at night to be like, where are you? What time are you coming home? I didn't have a lot of Fax Book adherence. So, okay. I should also say that part of what I do is building projects. It makes probably about half of the time that I work on stuff. The other half of the time I'm working on publishing stuff. And an approach that I've taken, I mean, I have like a academic monograph that's coming out from MIT Press and stuff like that, hopefully next year on DIY electronics and culture. But I do the traditional kind of also scientific publishing. If anybody's here, computer science, like conferences like CHI or 4S. But I'm also like kind of frustrated about the whole system of academic publishing, which has massive benefits, but then has the downside of you're never really quite sure who's reading your paper, who's paying attention to it, if 4 people show up to your talk at the conference, and I don't know if anybody, any faculty here been on these panels where, you know, like, it's like you and a couple friends at a panel. So part of what I've done is try to, I don't want to get into Trump right now, Clinton. Part of the thing is to try to produce small publications and give them to people as a gift, kind of as a bookmaking kind of exercise. So trying to kind of push academic publishing in different formats. So this particular project, called Disobedient Electronics, I had moved to Canada 5 years ago. As you may know, there was an election here, which, you know, according to who you talk to, was either fabulous or the worst thing in the world ever. And there was a lot of, there was Women's March, and a number of different kind of, you know, people protesting in the streets, kind of reminiscent to the Occupy Wall Street movement or something like that. There's kind of an upsurge in this kind of public protest. At the same time, I also knew of many different kind of fields. These are kind of terms with the corresponding authors. I was familiar with other designers, makers, experimental artists, designers that were using design work and built objects in an interesting kind of way. I wouldn't quite call it like a protest kind of design, but interested in social issues of work beyond just solving for kind of standard goals of efficiency. So the way that I work this is and I've done this a few times with a couple different book series that I've produced. But in this one, I had, I basically said to people, submit to me your projects for how electronics can be disobedient. In other words, how they can kind of question the status quo of society and culture. And you send me your stuff, I will produce a handmade book in a series of 300. I will give them to like the most interesting people I know in the world that are working in this kind of area, and I'll give you a bunch of copies that you can give to your friends. And so sort of was like working on this like trading zine, kind of a little bit more like subculture kind of publishing, but within academia. So I also offered it for free to people that were teaching classes, you know, professors that were interested in including it as part of their curriculum, exhibitions, and so forth. So I kind of was like, got this publication together. So printed up 300 copies, inkjet, printed it, looks like this. It was the video that I was playing during the introductions. So it looks like this. And there are a couple of themes and different projects that I'd like to highlight here that I think are, I think that there's a use for people protesting all sorts of different social issues, but I do see a limit in just sort of going out into the streets and yelling or holding a sign, no matter whatever side of whatever argument. I mean, I think there's a place for that, but then there are other ways that you can create things that are much more nuanced and much more interesting and much more productive in terms of actually talking about specific issues. A couple of things. I had a lot of submissions from people doing stuff related to gender and also women's health. Some of them were quite actually technically extremely simple, but were done in a way that raised different social issues around the world. This is a project done by a group in Germany, and they did this project as kind of like a media splash type of approach, almost like a viral video type of approach, where they had a drone carrying these morning after pills across the border from Germany, where it was legal, over to Poland and landing there, and a woman taking the pills. Now they knew that she was going to get arrested, and they the police were there like waiting for this, right? So yes, it is a publicity stunt, but it's also kind of interesting to think about how different laws change over a border. Borders are there's a lot to be said about borders, but how this medication is legal in one place and not in the other is something that I thought that for getting like $1,000 drone and taping on some pills, it actually is pretty efficient use of making an argument in a pretty lean kind of way. This is a project, and I should reiterate that these projects aren't mine. I was involved in doing the book layout and book printing of this. This isn't my project, but one that I highlighted through my publishing work. This is a project that's based off of the idea that women get paid less on average for guys for the same work. I mean, the exact figure is in the U.S. across all kind of social classes is estimated to be around 79%. And this was a very simple kind of clock that if you see the hand there, it says 79%. The idea, that's an alarm, okay? And in terms of the engineering of this, very, very simple. It's just a clock circuit that you buy at like a dollar store, shoved into a CNC, piece of wood and painted piece of metal. But it's actually quite sophisticated in how it's deployed. So you can set the alarm and the idea is that you can set it to 79% of your workday. So let's say you work 9 to 5 and 79% of your workday is 3:05 p.m., something like that. I don't know if that's actually 79%, but the idea is that this alarm goes off in your office and this thing beeps for a while at that 79% of your workday. Then the idea is that, I don't know if the women go out for like martinis or daiquiris or whatever, or they just kind of hear the thing beeping in a particular place where it's, in an office, or the women kind of think, well, it sure be nice if I got paid, the same as my male counterparts or whatever, or the guys in the office can just hear and go like, oh yeah, I hadn't really thought of that. But it's a way to make kind of a point that I think is a lot more interesting than just kind of yelling out something on a street corner or a graph that you see in a newspaper. Because ultimately, the location that you deploy this is an essential part, the audience of this, like in an engineering or computer science perspective, the user is very different in the context if you're in humanities. So this is, I think, quite an interesting project. There were other people this was a kind of a female duo in Denmark that was kind of questioning whether everything should be on the internet, and they kind of made this panties to tweet out while you're having your period as an intentionally horrible idea. But they did it as like a fake kind of Kickstarter, and they do like a professional kind of presentation of that this is like the next greatest thing about social networking. But they were not proposing that this is a good idea. Other projects, I included some historical projects. This, you probably can't read this, but it's a set of instructions for, Mattel had released Talking Barbie in 1983, and it said a bunch of like, basically like science, it literally said like math is hard, science is difficult, and this sort of stuff. And a bunch of parents were like, well, like, that's like not really helping the girls that are playing with this stuff to go, you know, to places like Harvey Mudd. And so what this group of parents did, and some artists and some hacker types, they took the in 1983, they took the G.I. Joe, talking G.I. Joe, who says things like, die, you know, kill, you know. And they swapped it with the Barbie and said stuff like, math is hard, and let's go shopping. And so they actually swapped the voice boxes. And if, you know, from an electrical standpoint, it's incredibly simple. It's just desoldering a few things and swapping them. And then they put them back into the stores. put in kind of leaflets that talked about the project. And surprisingly, it had a massive impact on Mattel during Christmas of 1983, where they recalled the product and they re-engineered it and stuff like this. But it's like totally, I think it's totally fun and totally brilliant and much more, I would much rather somebody, if they're going to be talking about the topic of women in science, I would much rather see like G.I. Joe doll who talks about going shopping and stuff like that. I mean, it's just, it has a humor to it that I think opens people up to kind of listening to what the argument they were making. In the case that this toy wasn't really helping girls and women go into science. There's a couple other projects. I'm not going to go through all of these, but people working with fabric and circuits actually engineered into fabric. Actually, for this project, and this sweater is a radio with some power control circuit there. I had a really hard time believing that this thing was real, and had them send me documentation of the stuff. They're actually building like discrete electronic circuits in like knitting with stuff, and it's just like totally kind of mind-blowing. Now this isn't like obviously really practical, but in circumstances where like it's like who needs a sweater that transmits an FM radio station? Probably not a lot of people. But in circumstances like what's happening in Hong Kong or whatever, where you have, you know, a lot of control over communication, apps being banned, and this kind of stuff, there's a small group of people who are very much interested in alternative kind of networks and alternate forms of communication. There also were some people who submitted stuff who were doing pretty kind of, I would say like pretty standard kind of like industrial design kind of work, but they were designing these kind of products specifically for people in protests. And it was very different. I mean, it's not like anything like this is super revolutionary. Like if you know electrical engineering, you'll know that, you know, you could do this with like some ESP32 chip or whatever pretty easily. But typically when you're designing products, there's not a lot of products that are made for people that are protesting. It's a weird and kind of interesting kind of use case to take as your subject of design people and circumstances that are normally not thought of. It's actually a really fantastic way to find new areas of research and innovation, is to look at what's not being designed for and to try to brainstorm around kind of taking that marginal thing and putting it into the center and reorienting around certain technology or context to be the center. And actually, if you stick around, I'm doing a workshop after this. We'll be doing some of this stuff with a set of cards and some papers and stuff like that. After the talk, I'll be doing a workshop and kind of workshopping this a little bit. Won't be doing any soldering and manufacturing or 3D printing, but just doing it on paper. Robots that wrote out graffiti, like kind of like a dot matrix printer that runs along the ground with a bunch of spray cans. other people, I mean, this is an interesting project that I found it quite interesting because it's not explicitly pro or anti-military, but the way that this thing works is that it has a small needle, kind of similar to what you prick your finger with if you are doing a like diabetes blood test, and a little pin that jabs you in the arm whenever there's a recorded death in the U.S. military. Now this isn't proposed to be, you know, some fashion accessory. This is designed more, you know, to sit in a gallery or photographs or maybe by video. But I think it's worthwhile noting because it often with statistics, data, graphs, and stuff like this, there's many different ways to make that information visible and legible in ways that maybe a pie chart or bar graph doesn't really kind of do. And I'm not suggesting that maybe this is like the solution to everything, but I definitely think that there's a place to make information legible in other ways that, like it does make more sense to actually visualize people dying with some pain. This is not the standard, you know, Microsoft Excel kind of way to visualize information, but it's something that's interesting and that actually raises an issue in a way that's actually quite kind of nuanced. You know, it's not like military is bad, war is bad, but just kind of like this person died, you know, this person died, and visualize. Well, technically it's not visualizing it, but it's making it kind of felt. There were a few people who did projects related to privacy, especially online privacy, and there still is a lot of concern in popular culture around large companies owning massive amounts of information on people, and online privacy is, for many people, a very big topic. So this project was basically a Wi-Fi router that had a large knob on the front that you could turn to be like a standard kind of Wi-Fi hub, to being encrypted, you know, like everything encrypted, and then you turn it more, and it's like everything goes through a Tor network, which is like an anonymous, anonymizing kind of layer of the internet, or you can just turn it completely off. But if you think about a topic like, so this is like an example of a product where it's not necessarily just trying to improve the bandwidth of the network connection. You know, it's sort of it's not the standard kind of efficiency, but it's kind of taking the case of somebody very concerned about privacy and kind of taking that as a center point for a launch point for design. This is a project with electrical solenoids that hammer away on a keyboard randomly to kind of mess up your ad profile, and also just if you're paranoid over people watching you. I mean, definitely a lot of the security stuff is, I mean, a lot of it is justified, but then also there's definitely a conspiracy component to a lot of the stuff. But it kind of simulates a cat walking across your keyboard randomly and bashing away at stuff. The idea of this is to create more noise in the system of how you use the internet, so that it's harder to track you, whether it's advertising, or some company, or Facebook, or government, or whoever. There's a few other projects that had to do with the environment, people building solar cookers and stuff like that. But all said and done, when I published this, oh, and I should say that if anybody is into making small pamphlets or booklets, this is a very quick, easy hack. If you have an old sewing machine running around, you just put the plain old paper through a sewing machine and fold it. It makes a beautiful little booklet. It's a very easy way to buy books in a kind of a stylish way. So I gave this away for free to contributors.